Rob is the chief engineer for WAMU and graciously put this whole meeting together for us. Thanks very much, and if you could introduce our guests.
Sure. Well, thanks everybody for being here, and this is a special night for us here at WAMU, and really glad to welcome you to this building. This is the American University Media Production Center. It was built in 1961 by WJLA, actually. It was a gift to American University in exchange for being able to build this tower. 10 years, a little bit more than 10 years prior. This was sort of the deal, was if AU provided space for this tower, that WJLA would provide a building for students to learn this newfangled television thing. And WAMU was born in this building as well. So we were located on the upper floor here. This has always been a television production facility here in this room. There used to be a control room on the side. And to be honest, this building, it really started to gather some cobwebs up until 2019, when they launched a new photo major here at the university, and they turned what was really WAMU's edit booths in the upper floors that had been kind of just being used for various things over the years into some really beautiful photo labs. So we're grateful to be in the space and grateful to our friends at the American University School of Communication for giving us this space. Some of you may have heard me talking about earlier, when WAMU went on the air in 1961, our transmitter, which was used and given to us by WGBH in Boston, was located in a storage closet in the corner of this room. So this room has a lot of special history for us here at WAMU. And thanks for being here.
You want to introduce
Yeah.
you guys? I don't know everybody's name, but I know, of course, know Tom, but go ahead.
Sure. This is Tom Silliman, who is here as president and CEO of Electronics Research. I don't think that Tom needs that intense of an introduction. Andy Gunn, who's the director of engineering here at WAMU, and Nick, I'm so sorry that I'm blanking. Paul said that. Paulin. I was about to say Paul. I'm like, no, that's not it. Nick Paulin, who is the head of the filter lab at Electronic Research. So Nick and his team designed the combiner that we'll see, and Nick will be giving a talk about the combiner when we do the tour in just a bit.
Great. Guess we're ready. Yeah.
And if you'll bear with me for just a second so I can share my screen with the folks on Zoom. One of the challenges of modern hybrid life, right?
You guys see it okay?
It looks like we have been successful there. Great. So yeah, thank you everybody for being here. Another really interesting note was that the journey towards this project, one part of it actually also began in this room in a conversation with Cindy Cabell and Mike Rhodes. We were seated on these little student tables over in the corner, kind of strategizing about what sort of story would be really helpful to explain to the university as to why this project needed to happen. So in terms of what we're going to talk about tonight, I'm going to talk a little bit about the origins, the genesis of this project. Tom is going to talk about the technology behind the antenna system itself, and Andy is going to talk about what it's been like to build it. And Nick, when we're on the tour, we'll talk about what it was like to design the combiner and be able to go through the actual bits and pieces of it as well, which should be a real special treat. So thank you all for being here. I came to WAMU from CBS Radio in New York in 2016, and I had never really seen anything like this antenna system before, not even when I started off in New Jersey radio. And to be honest, I wasn't actually sure if what I was seeing on this tower was strange, or if I just was not worldly enough to understand that this is how things operated in the real world. And I went to NAB after being here for about a week. And really quickly, our friends at WTOP grabbed me and said, we need to go to the ERI booth together and have a conversation. And that was maybe the very first conversation that led us to where we are today. I want to say thank you to Mike Rhodes from Cavell Mertz for this really, really clear graphic. And it's important to note that when this was built in 1990, this all made sense, this wild mass of interleaved antennas. These were mostly small stations. There was also a directional backup for WPGC up there at the top. Then and now the tower house is 6 FMs, 4 mains, and 2 auxes. And really, if we're being honest, the ratings and the revenue for these stations in 1990 just did not support a multi-million-dollar investment in this antenna system. So the stations worked with Shively to come up with this very unique arrangement of interleaved antennas. And not long after, the directional dielectric up top was added for WPGC. Even though this made good financial sense at the time, from an RF standpoint, as you might imagine, it did present some operational concerns for some of the stations. I want to acknowledge that there was a fairly substantial drive test done from mostly from our friends at WTOP to bear out that this did present some real operational concerns to us. You can see just a little bit of a 10-bay Shively with radomes there on the side. And further below that, there is an aux that is still there that served as an aux for WAMU and WTA. That 10-bay served WPFW. And so now 30 years today, after all this was built, these stations are in a very different place at the top of the ratings and the revenue heap. In fact, WTOP, WAMU, and WMMJ are routinely in the top 5 in the ratings. Even though MMJ is a Class A with a considerably smaller signal than the other two, they really outperform from this tower here in DC. It is indeed in a sweet spot for serving the DC metro. So engineers made technical arguments to the university for many years about why a combined antenna system should be built. But as perhaps you've experienced, technical arguments don't always get all the traction that we hope that they might. We knew that we had to find a different approach to making this happen, but there had never really been a real sense of urgency around it. And then suddenly it became urgent the day that I got this email. About a year into my time at WAMU, I sent along a potential new client to the real estate folks at the university, and they decided to pass on it. Specifically, the email says, good morning to me. I believe my boss has communicated with your boss. We are engaging a broker to sell the tower. I don't think it would be appropriate to move forward with anything at this time. That was a heck of an email to get at 7:15 or whatever time, 7:05 on a random Wednesday morning. They figured that the university would be better served by not having to manage this strange tower anymore and maybe get some cash out of selling it at the same time. So very quickly realized that first we had to educate folks as to what the tower meant, what it was for WAMU and for the other broadcasters that were there as well, but for an asset that the university really, really cherished, that this was not simply an office building, that this was central to WAMU's existence. And that took a number of years. In fact, we'd spent the next several years building out the business case for why AU would be better served if we ran the tower for them. But as happens in many circumstances, several reports were presented to university leadership, one about what the tower should sell for, and the other about why our proposed master FM system was a terrible idea. There was even an earlier report along those same lines from 2015. This was my introduction to university politics, and I had a whole lot to learn very quickly. I was clearly no longer working for a broadcast company, and I needed to get smarter fast about how to succeed in this quest at a university because there is a whole lot on the line. By sheer coincidence, not long after getting those reports, Tony Peterly from WorldCast happened to stop by our studio when he was in town. And he brought along another engineer named David Gates, who runs a firm called Season Communications. Maybe some of you know him. The potential sale of this tower was very much top of my mind that day, and I might have been ranting a little bit about it. And David was intrigued, and he offered to take a look at those reports if I would send them to him. And he read them, and he got at least as worked up about what these reports had to say as I did. And so we wound up hiring him to perform a written analysis of the consultant reports as a disinterested third party, and he provided a point-by-point rebuttal to all of the claims in those reports. And we were so pleased with the outcome of David's report that we asked several consultants to weigh in on some questions for us, including the folks at Cavell Mertz and at Communication Technologies. We also asked vendors like ERI and a broker that I knew from my days in New York for their take on this situation. We also built new relationships across the university. My boss, WAMU's general manager, had a lot to do with laying that groundwork already. We had partnered with his boss, the chief of staff to the president, to navigate the complex university landscape. And along the way, convinced the head of IT to back our plan, which I learned up until that point that he did not quite understand how central the tower was to us. It just wasn't part of his world. And as soon as he understood, he was very quickly a vocal supporter of this, which was great. Eventually, we sat down for a very, very thorough vetting of our business case by the budget office, where they poured through our numbers and ultimately decided that they made sense. So long before a single technical thing happened, before a single line was drawn on a page, I wrote more than I ever had in my life. And it quickly became apparent to me that writing for a journalist boss in public media was very different than writing for a finance boss in my prior life in commercial media. I learned a whole lot, definitely developed a thicker skin and learned to take criticism a bit more gracefully. And in the end, we produced some really, really compelling material together. And I can say, as an engineer, that we would not have been able to produce sort of the level of understandable storytelling that we did in the end for the folks who were the decision makers. So in the end, what won the day was all of these things. It was the abundance of expert data, the coalition that we built across the university, and probably most importantly, the detailed business plan that we had put together. We were able to prove that this investment would be repaid in less than 7 years, and the tower would become much more valuable, even if we did decide to sell it. But really, a big part of making that possible was convincing WTOP, which wasn't very hard to do because they very much wanted to be part of this, to come in as a full-fledged partner on this build. WTOP covered half the cost of the antenna system itself and other common portions of the system. Having that partnership is what made this project possible. Dave Garner and I sat down at what was a really unique and momentous meeting of the heads of our organization. And it was really something to have the general manager of WTOP and the general manager of WAMU, two fierce ratings rivals, sit down and say, yeah, we're gonna go in on this. And then to get a letter from the general manager of WTOP to the leadership of American University saying, we are going to put our money where our mouths are, and we're willing to be part of this. Without TOP's partnership, this would not have happened. So this system is as much about WTOP as it is about WAMU. Well, WAMU fronted all the costs related to the tower reinforcement, which was interesting because if you remember the steel tariff shenanigans that were going on, this was at the height of that. We also took care of the ground level construction and the big pole. Again, without TOP, this would not have happened. By the way, I invite any of my TOP friends to talk about the project tonight while we're together. You know, it's really pretty incredible that we have almost the entire community involved with this tower here in this room tonight, as well as the broader engineering community. I didn't see Tom come in, Shedlick, but minus WPGC, the rest of us are here, which is pretty cool. We'll talk about PFW in just a few minutes because PFW is a big part of this story too. You know, in the end, WAMU and all of us wound up with a world-class facility and much stronger signals, which also made a compelling case for WAMU to sell our 2 satellite signals that were out on the Eastern Shore and down in Virginia. And we're able to reinvest that ongoing budget in digital growth. At the end of the day, not only had we convinced the university to greenlight a $2+ million tower upgrade, but they transferred the entire tower operation to us to operate. And we now run it as a business unit of the station, receiving its revenues and managing its expenses. In fact, my colleague Kim Boone is here tonight, and she is the one who is charged with day-to-day operations. Not to put you on the spot, Tim. And I also want to acknowledge my other WAMU colleagues who have come out tonight. Thank you for being here. Ultimately, after we got the university CFO on board, we had to summarize the terms that we had agreed to and then write this up for the president of the university to sign. My boss described that meeting with the president of the university as one of the most intense that he had ever had in his life. You can see her highlighting if you look closely at that document there and a bunch of notes scribbled on it. She had lots of really smart questions, which we answered, and she ultimately gave her formal sign off. When I went to go and pull her photo off of the AU website, there was this particularly poignant pull quote here, which is a little bit hard to read in the back, but she says, that's the future that we're building here at American University, one of partnerships of and, not or, grounded in our community, with our eyes set on the horizon, looking toward the future, a place for change makers. And it's really nice to be able to say that you actually live your values. And I'm really, really proud of American University for doing that for this tower, and in many things that they're involved with, but the support of Sylvia Burwell was key to making this happen. As you might imagine, in fact, as those in this room lived, cutting the top 100 feet off of your tower meant some pretty heart-stopping moments, and meant operating from lower powered backup sites for several months, which was a scary proposition. So we mailed a postcard to every address we had in our database, which was about 80,000 people, and we ran lots of promos on the air. In the end, we heard from almost nobody while we were operating over at WETA. But when the timeline dragged on for a number of reasons, we started to get some phone calls, and all those callers said to us, I know you're doing this thing with your tower, but your signal's still really static. When will it be done? But all of them acknowledged that they knew that we were rebuilding our towers, so it meant that the communication plan had worked. Notably, our ratings in the DC market never dropped, neither did WTOP's, despite all of us being at substantially lower power. I don't think that MMJ was impacted during that either.
We were operating from NBC, which is much higher in elevation.
Yeah, so we all did well. And in just a minute, Tom Silliman's going to talk about the unique antenna and the combiner system that ERI built and installed for us. Nick Paulin is also here, and as we talked about, is going to go through the system when we're in the combiner room. His team did the designs that you see on the screen, and he and Tom will be able to actually talk about the combiner as we tour it in just a bit. I'm not going to walk through the entire tower design, but after what I just described, you can imagine how elated we were to get to the stage of these drawings. I'll never forget the day that we got the 3D rendering of the combiner, and I ran down the hall to Andy's office. I'm like, Andy, you have to look at this. I loaded it on my phone. It spins around. We can like fly through it, pinch and zoom. I was so excited.
It's true.
So here's a quick couple of photos of the project before I hand it off to Tom. And you know, it's really amazing to see lines on a page take shape in real life. There is so much detail in this drawing. In fact, I'd never actually put this drawing next to this photo until we did this presentation at NAB. And so much precision went into drawing and building all of this out. If you look closely at that photo, you'll also see 5 tower techs from VTS. You might not be able to see that from the back of the room, but they're all kind of embedded in the mesh of the tower, and a couple at the bottom of the pole there. You know, I'll always remember the meeting with ERI when we first looked at this drawing, and Tom, this might have been the first time that Tom saw this drawing from the team. He said, well, it's certainly going to be a weird looking thing, isn't it? Kind of like a fly swatter on top of a tower, but also one of the most beautiful things that you will have ever seen, which I would say is true. I think that's held up. It's unique and beautiful. And it's just so super remarkable the way that ERI and their in-house structural design team led the way on the tower reinforcement through, you know, for the whole length of the tower, working with our local engineers through Morris Ritchie Associates to pull all of that complexity together. Super unique to have RF and structural design and manufacturing and construction all under one roof at a manufacturer. It was a big day, the day that they cut the pole off of the tower to make room for the new pole. Here, Craig Fowler, who is the tower crew foreman from VTS, paused to take a pretty awesome selfie as the crane held that pole up in the air. It was official. Our tower was no longer operable. We had burned the boats. There was no way to go back. It was a little heart-stopping. All of us were already on our aux sites by that point, and we would stay there for the next few months. But a new antenna system meant that WPFW needed a bigger transmitter. So we needed a bigger transmitter for WAMU as well. And so we sold them our Nautel NV40, and they have given it a terrific home. And in fact, Mo Thomas called me up after Mo was over there, said, well, you know, so Rob, we're really glad to be getting your transmitter, but you know, our crappy transmitter building is not really a great home for that. What are you going to do about it? And so we did renovate the WPFW transmitter building, which is you know, something that is on us as the landlords of this facility. It was a hastily converted generator building. This was the generator building for WJLA TV. And in the 1970s, when PFW joined the tower, I think that they had just taken the generator out of the room and put the transmitter in. I mean, there was still open grills, like wind whipped through there. It was a rough room. So Mo was right to say we need a better transmitter room. I also want to note Kim Boone was the one who managed this project. And so to create a proper home, we did renovate the shelter, and it, you know, if I say so, it turned out pretty great. You can see the NV40 leaving our room over there and traveling down around the back of the building. And there it is in its new home with lots of patching to the walls, a few coats of paint and a new floor. And it's shiny and new. But we also needed some place to put the combiner and the standalone filters. So we, in the building, as you'll see, has no room for any of that. So we squeezed in a built-on-site shelter from VFP. I want to say thanks to Art Rose, who was the one who said, hey, you need a building, you should talk to these people at VFP. TOP had bought one for one of the satellite signals. And it was a great recommendation. They were awesome to work with. That as you walk back to the combiner building, what's really notable is that this building is entirely assembled of 12-inch panels, and it showed up on what was essentially a landscaping trailer. And so as you walk back to the combiner building, notable that this entire building in 12-inch sections traveled those sidewalks by hand, being offloaded from a landscaping trailer in the parking lot out here. It was really something to watch all of that come together. But with the building done, ERI's expert field techs got to work. I knew their workmanship from my time at the Empire State Building, but it was really, really something to watch them stack all these filters and plumb all of those lines. All the pieces were finally coming together, and Troy Knotts and Jeff Taylor in these photos are really something to watch in action. And Jeff is a pretty good comedian as well. If you have ever worked with him, you may know that, but he always kept Andy and I laughing throughout the project. The final night that we turned the system up, staff from WAMU, WPGC, WPFW, WTOP, WMNJ, WETA, and Paul Schulens, who was there for Burke. Andy and I posing with the Burke Arcturus Viswar protection system, all green lights and good to go. He's going to talk about the Arcturus in just a couple minutes. But then this photo going through everything just seemed to really tell 1,000 words. Here's Kevin Fisher, who some of you may know, RFR consultant. He's wearing a mask a few weeks after we went live, taking measurements in the combiner shelter. And yeah, by that point, we were all wearing masks. In fact, I think that there is our ceremonial box of Clorox wipes that's still sitting on top of the fire extinguisher in that room. That will always be a reminder of that time when we thought we all needed to wipe everything down, because that's how these things talk, right? But the day that ERI left the site in March of 2020, we had to pause doing further work on the system. It was on the air, but it seemed like this whole COVID situation was maybe going to be a thing. And neither TOP nor AMU wanted to drop to our aux sites as this situation was ramping up. Also, we all needed to get back to the studio to get everybody set up to work from home, which was just, I mean, literally the day that this went on the air, Andy and I turned to each other in the combiner shelter and said, well, I guess we have to go back to the studio, like literally at that minute, and say, well, let's figure out what this means to get people out of the building. There was no rest between this and COVID. Once things stabilized a bit, we turned our attention back to this massive project and started to move a little bit beyond our sense that there was something a little off, and started to drill down on the issues. The system fully checked out at launch. It just didn't sound right. All of the parameters were correct though. WAMU's audio sounded a little crispy, and we seemed to have multipath in a whole bunch of places that we didn't before. It got worse the closer that you got to the tower. By the way, it's just super interesting to watch Tom's gears turning every time that we would describe something. You could see that he was playing through any number of scenarios in his head, and did very much come up with the root cause of it. But back when we were planning the project out, I had decided to hire Kevin because I knew that Tom knew him from Empire, and I knew that if there was any kind of an issue, that Tom would probably trust him. And a college campus in this particular neighborhood in DC are pretty sensitive places, so we couldn't be too careful. We wanted to make sure that we were being responsible to the community of AU and to the greater community beyond this in terms of RF measurements. Sure enough, there as he was taking measurements in his mask, Kevin turned up some pretty serious RF leaks in the system in the combiner shelter itself. When we reached out to ERI to talk about it, it confirmed Tom's suspicions. Those gears that I saw turning in his head, he was now able to connect all of those dots for us and fill us in on what was going on. And we'd spend the next few months with ERI working with them to get it right. And I really, really want to say that ERI never, ever backed down. This was a difficult time. It was during COVID, it was during repack, and ERI stuck with it. Here's a shot of troubleshooting, which ranged from careful strategic application of foil tape to wholesale remanufacturing of the filter cans. ERI never, ever relented. They kept at it until it was right. And given the time period, this is even more notable. I've certainly worked with other manufacturers in much calmer times who never gave us this level of attention. And I really want to publicly thank ERI for everything that went into this project. I've sort of lost track of the number of follow-up trips. I think it was about 4 that all happened during the pandemic. ERI dug into the issues, rebuilding the site in their filter lab over and over again, replacing one section of the system and then another, proving out theory after theory until they got it. As is always frustrating, there was more than one issue at play, which made it really, really hard to troubleshoot. But again, ERI stuck with it, kept coming back, kept redesigning and remanufacturing. You'll get to see the evolution of this design in just a bit. And Tom and Nick can speak to this. We found the sources of the RF leaks. The filters have been redesigned. Lots of hunting and lots of creativity, but we got to the end of it. And in the end, regardless of the return trips, we gathered for this photo and even took off our masks. I remember that was a big deal, that we were all close to each other. Like, well, I guess we could take off our masks just to snap this photo. Me and Kim are huddled behind Andy there, and the rest of the crew, including Tom from ERI. I am so grateful to ERI for this project. I can't think of another company who could have done everything that they did, who would have had these capabilities in-house, the in-house expertise to take on a project of this magnitude. We could have never seen COVID or the repack. Well, we saw the repack coming, but COVID or the steel tariffs or all of the political complexity of the university that came before any of that. But ERI stuck with us, and several years later, the system is humming along like it has always been there. The station signals are all stronger and cleaner. We are reaching communities that we actually didn't before. WAMU has been the #1 station in Washington for over a year now. We sport some incredibly high time spent listening amongst an audience who largely listens at home. And I have no doubt that our antenna system helps us sustain the cleanest signal that we've ever delivered to the greatest number of people. So let me turn it over to Tom to tell you about the system itself. Tom, thank you for making the trip and for dinner tonight.
What was interesting that we found was that the company that rolls our tanks and welds the seam along the edge, they decided they didn't have to weld it as well. So instead of doing an inside and outside path weld, they just ran a simple bead on the outside. And when we discovered this, we realized that the filters were leaking RF into the room. So we took all the filters back to Indiana, re-welded them. We had our filter company come in and showed them what the problem was and raised hell with them for doing it. Made them take the tanks back, add the second weld, and then bring them back to us. And then we put them back together and retuned them and brought them back and installed them a second time. And they worked. So it was a painful experience, but it wasn't our fault. It was our supplier's fault. And so now we have a better QC program in place. The overall project for us is we're a very different company in that we have an internal structural engineering department right now with 2 PEs. Nick and I are both PEs as well. And Nick runs the filter department, and I look in the mirror to find my boss. But anyway, you can kind of see the summary there of what it had with the main and auxiliary antennas and whatnot in operations. But what's really neat about the antenna is that the main antenna, it has a right hand and a left hand CP input. And the way the antenna, and I'll show you the way the antenna is designed in a minute, because you can kind of see, because we have the picture looking in the end of it. But WTOP, it has a different pattern than the ones that are right hand CP. The right hand is this route, right? Okay, and the way we did that was the antenna, which you can see here is wrapped around the pole with wings to control the pattern. It has a separate feed line that comes up for the WTOP feed. And it has a separate power splitter to split the power between the phase between the elements to create the directional pattern. And the antenna itself has a 3 dB hybrid on its input with 2 ports to go into 280-degree balance. And for the right-hand CP, everything's fed in phase and magnitude, which you'll see here in a minute. There's kind of a little diagram that's hard to see, but it shows that there's 2 feed lines coming up the tower. One's a 6-inch feed for the multiplex stations, and the other is a 3-inch feed for WTOP. On the back of the antenna, you can kind of see over on the right, that little box. The counterclockwise input is marked on the top, and the clockwise is on the bottom. And the hybrid has 2 outputs that feed the antenna, and the 280-degree balance provide the phases that we feed the 4 arms. If you look at the end of the antenna with the cap off, you can kind of see the 4 tubes and then the little straps that feed the actual elements from the inside on insulated feeds. And then they excite the 4 monopoles. And that gives you and you can kind of see on the right, the swept back arms. There's 4 arms on each antenna mounted to the insulators. And they're fed inside. The end of it is a huge melamine insulator, so that the feed point is fully pressurized. And the little feeds are designed so that the one hybrid input feeds it one way and the other feeds it the other way. And that's how we did the 2 different patterns. There's kind of a diagram of the 4-bay antenna. And it sort of shows that it's got separate feed harnesses for the 2 sides. And now, if you look at the pattern on the left, you can see that it's got a null in the back. And if you look at the pattern on the right, you can see that it's pretty round. These are the different patterns for the right-hand CP, and you can see that they are pretty much circles. Whereas the TOP input on the left-hand CP is definitely a directional. At our factory, we also own a testing facility in Boonville, Indiana, that's not on our campus. That's a 50-acre facility that we own. And there we have turntables that are rated at 56 kilo, they're rated for overturn and downward, so that they can be used to test antennas and turn them. And we have a pattern range that's there to measure them, so we can actually measure these patterns. And there's the antenna being set on one of our test stands to match it. And there on the right, you can kind of see the antenna laying on its side at our factory. 100-acre facility we have there in Chandler, Indiana. Here you can see the people working on the antenna, and then there on the left side, you can kind of see it. Getting ready to go up here at the tower site. And there it is. The filter system, the way we do filter systems for places like this is once we knew what the building shape was gonna be, we got the dimensions of the building, the height of the room, and the inside dimensions from Rob. And then Nick went back to his filter lab and laid out the floor with the dimensions that the building had, so that his team can then figure out how to get these damn filters in that room and make them fit. And not only was it difficult to get them in, but we had to know where the door was so that we could get them in and install them and then mount them properly. And we also make patch panels, which are in there, and switches in his department, and coaxial switches, and the filters, we stood them on end like we did on the Empire State Building, because otherwise they would have never fit in that room. And you could kind of see the labels on this sort of show where the different filters are. Like some of them are constant impedance with 2 banks of filters and a hybrid at the bottom and the top, so that the next station can go into the hybrid at the bottom, and that the individual station can feed the hybrid at the top. And then all the signals travel around the room and then go to the antenna. Some of them, I think one of them is just a single stack of filters, and that's for one of the 2-bay antennas, right? Yeah. There's kind of a schematic of it. So before it was taken apart, before it was labeled, taken apart and shipped to Washington, DC, it was fully tested, verify the station to station isolation, as well as the return loss through the filters. And the rack panel with the patches, which you'll see when we leave this room and go over to the brick building at the base of the tower, is mounted along the wall on the one side of the building away from the door. And stations can go through there where they can get patched and whatnot. When we came here and looked at the site, and we realized we were going to unload our filters in the parking lot where about here, we realized to get them over there, we'd have to go over the stairs and come back down, and we'd have to go across the rocks. And we were worried about bouncing filters around, so we built ramps, which are here in storage somewhere, I assume, so that we could go up over the stairs. And you kind of see in the third from the left on the top, you see that angled board that goes up on the stairs, and you'll see when we go around back, so we could two-wheel each filter in, wheel it up on the stairs, wheel it down the other side, and then across the rocks. We laid these boards so that we could get in easily. So we put a lot of thought into that. And then on the bottom pictures, you can kind of see us in there organizing things and moving them around. At this point, I'm going to turn it over to Andy Gunn, because he's going to talk about the monitoring system that they bought from Berg. And Andy, it's all yours.
All right, thank you, Tom. Yeah, so once everything is installed and tested and swept, and the transmitters are on the air, so then what? What do you do from there? We needed to make sure that everything stays happy and healthy for the long run. So prior to the things getting built and the antenna project really starting, we started to talk to Berg Technology about designing a Viswar protection system for us based on the combiner and antenna design that ERI had provided. And when we started out, we had a lot of lofty ideas. Rob and I had a number of conversations about, oh, we need this, we're gonna have these redundancies and all these systems. So we got really excited about that. And Berg listened, and they mostly shook their head and said yes, and agreed with us on a lot of these crazy ideas. And so a lot of our conditions were, pretty reasonable, but we designed it for a lot of redundancy and to make sure that it would pretty much always work. So we needed instant interlock opening capability. So each of the Burke, Arcturus, Viswar units, they operate independently. So if the Arcturus system goes down or the autopilot's not functioning or anything like that, it'll still work and it'll open and interlock if there's a Viswar event. We needed dual interlock strings, so every station would get 2 pairs. So if any one wire gets cut or pulled, the system would still deliver interlocks. We had a lot of detailed monitoring points that we wanted, including U-links that we wanted so we could totally safe out the system for any tower climbers. We wanted to monitor temperatures on the combiners. We wanted a dual dehydrator system so that if we lost a dehydrator, we could still keep the system fully pressurized and even out wear between the 2 of them. We wanted a strip line trend monitoring for a number of things and the ability to lock out stations, either in software or just a simple dumb key on the panel. And so they looked at us and said, all right, we're going to do this. So the physical integration and installation of Arcturus was done by Paul Schulens of Schulens Solutions through Burke Technology. And, I think Rob had specifically asked to work with Paul because of your experiences working with him in the past. Is that right? Yeah. And we were impressed with his work. The installation went really smoothly. And per Burke's documentation, we went back and forth and had a number of revisions, and Paul implemented it really well. And I worked with, or Mark Raymond from Burke Technology built out the software side. And so, there's many, many data points in the system. And he went through and, we talked about everything we wanted tracked. He created multiple views in autopilot so we could get a really detailed view of everything that was going on in the system and the health of all the different components at a glance. And, aside from overall summary views of the system, we have views for system-wide control of all the interlocks, as well as the ability to reset if there's a 3-strike lockout or anything like that. View of all the environmental conditions, including indoor and outdoor temperatures, air pressure in the lines, temperature of different combiner components, and a detailed view of each station's combiner, Viswar, forward and reflective power, all those things, temperatures. And we also get we would get notifications if anything went wrong, but we haven't had any problems. But it gives us notifications if there's a Viswar event, if a U-link is pulled, and WAMU engineers get all of the notifications on the system, so we would know immediately if anything was wrong, and every station that's in the system would get a notification if their particular signal was affected. So that way, I don't think anybody, correct me if I'm wrong, no problem so far. And so when we were putting things online and when we were designing the system, I worked really closely with Mark to iterate back and forth on the design and make sure that, they understood what we wanted. And Mark was great and worked with me really closely because the interlock strings are a little bit complex as we monitor U-links for each station, the Viswar conditions, and, we're delivering a pair to every transmitter room. The loops are all relay based and, normally closed. So a system failure or a power issue wouldn't take everybody down. And, the system has to actively open interlocks, but, so far, no problems there. We did discover some bugs and with some edge cases while we were testing, such as we went through and pulled every network connection out. We dropped power on different units at different times. And, there was some strange behavior in the initial testing of that, but we worked with Mark to make sure that these things were all fixed. And if any anomalies came up, it wouldn't take any one or any station off the air. So we were confident that we're good in that case. Mark also designed multiple strip charts for us so we could observe trends in the system. And we were particularly interested in how environmental effects, temperature, icing, et cetera, would relate to the visual of the overall system. We have some short-term graphs for all the stations, but we also have 3 one-year graphs for line pressure versus visual, outdoor temperature versus visual, and a third one who I didn't make a note on, but we can probably show you later. I'd have a screenshot of them here, but I recently changed out the computer, so it's not a full year showing on the strip charts, but anyway. Mark also worked to develop a system to monitor and cycle the dehydrators. We were really interested in keeping the lines pressurized. I think Rob has a horror story about Empire of, anyway, you should ask him about it, but lines burning out. And so
your eyes fall.
no, this was Empire's fault, right?
Yeah.
Yeah, anyway, that's a story for another time. And so we were really keen on keeping this running as best we could. And we also wanted to make sure that the wear was even on 2 dehydrators. So not just run one for a year, and then when I remember to go flick a switch to switch between them, it would actually cycle every 50 hours of runtime. And so the system keeps one of the 2 dehydrators active at any time and records how long it's actually running through a passive power sensor on the power line. And it allows us to see how long the dehydrator runs. So how long does it take to fully charge the lines? Which is helpful for diagnosing if there's a leak, as well as seeing how often that it actually runs. After the dehydrators run for a cumulative 50 hours, the Arcturus system will turn it off, turn the other one on, and then, as long as there's no alarms or it doesn't, it runs and functions, it'll keep that one on and running for 50 hours and then flip it back. And I can run reports on autopilot and see how well the system has been running and all those sorts of things. And I pretty much check it pretty weekly to make sure that there's no issues that crop up. I also developed through the course of this a few other simple macros to monitor the AC units in the combiner shelter. After last summer, both of them failed, and I got some temperature notifications from the Arcturus system on a very hot day. I think it was actually the 4th of July weekend, which our HVAC company was very sad about when I called them. But they came out and they fixed the units, which was fine. But I wanted some notification that if there was an issue with one of the 2 units, that we would know. And so they're essentially, when a unit runs, it starts a timer, and then if the timer goes longer than its lead lag time, I get a notification that a unit hasn't run in a certain number of days. And so that way, I know if a unit is broken, and because the backup unit would take over and keep the room cool, but the unit that was supposed to run, well, I would get a notification that it didn't run. And so since we already monitored the output of both AC units, this was relatively simple. And I just set the timer for longer than the lead lag controller between the 2 units runs for. And if it doesn't work, I get an alert. And then I also implemented this in our transmitter room, which has also saved us, as we had over the past year some problems with another AC unit. I hate cooling. And that's about it. I think we can talk more about that stuff through the tours. I didn't know if folks had any questions.
We should probably open up to questions here and for the people online too, because they can't go on the tour.
Yes, of course. So I'll get out of the way.
Do any of the engineers here have any comments? Or hold on, let me bring the mic to you.
Service.
Thank you.
One of the first slides that you opened with, Rob, was this unusual antenna pole. And now that it's no longer in service, I'm curious if the experts in RF could venture a guess as to what kind of intermodulation nightmares we all have been living with over the years.
Would you like to take that, Tom? We had some conversations about this at the factory. I mean, another thing that we didn't talk about with the pole that was also very interesting is that the pole was stepped. I often compare, if any of you are familiar with the 80s band Devo and the hats that they wore, that was sort of this pole, just instead of a 1 foot hat, it was 100 feet. But it varied by dimension. So for WAMU, we had a 6-bay antenna, and it was, I forget how many inches at the base, let's say maybe 12, and it was 6 up at the top. What did that do, having that different backing behind each bay? I don't know. Tom has had some thoughts on it, but I mean, the reality is that we never measured it. But yeah, what do you have to say about the prior antenna configuration?
The key thing on multi-station sites is to measure the port-to-port isolation between the transmitter ports, output ports, and then to calculate the products, and then measure the products with a tunable filter so that you can keep the receiver from overloading and creating its own products. And we've been doing that for years, and I don't know that an IM study was ever done on that antenna before. So I'm sure it was having some products, but the new system does not. It's clean. Another thing is, Andy was talking about VSWR with ICE and whatnot. The key thing about designing a panel antenna with a hybrid input is that you calculate what the feed line rating is inside the balun and inside the hybrid. And what happens is when if the antenna ICE is up, the hybrid basically cancels out the VSWR. So as long as you can take the current and voltage in the stem, then you won't have icing issues. And it's interesting because we've got pictures of our antennas like in Seattle on Tiger Mountain, where it looks like a snow cone. The antenna is totally buried in ice, but they're still in the air. And what's happened is that the standing wave in the balun does not exceed the line rating of the components in the antenna or the balun. So the new system is very compliant. The old system probably was not. Okay.
Thank
Excellent presentation, thank you. Do you have a running list of all the improvements that this work has produced for the stations?
A running list of improvements.
Yeah, so what has been improved, okay?
I mean, I'll
You know,
tell you-
for the, on the station side, but also for the listeners.
It's largely anecdotal. It's an interesting question. We haven't compiled such things. I will tell you, all of us, especially the night that we went live and in the days since, many of whom are sitting in this room, we all went and drove the signal. You know, TOP in particular, you know, TOP has these repeater signals as well. So their staff routinely exceeds the boundaries of, you know, city grade contour of the station and report, you know, notably improved signal strength out in there. You know, Dave Collisar, we had spoken a number of times about the impact that rain used to have on the old antenna. And that is no longer a thing. We never see, of course, never see rain, we never see ice, you know, I mean, it's really pretty incredible. A lot of it is anecdotal. You know, we just got a comment, it's how long has it been? Almost 3 years since we've gone on. Just last week, we got an email from a listener complimenting us on the improved signal strength. That said, I mean, we also hear from people when they don't get the station. That's sort of the nature of broadcast engineering, isn't it? That we always hear from people when they don't get the station. But yeah, we don't have a consolidated list. I will say that, I mean, the feedback has been tremendous from some folks who are in this room or on this call. You know, not to single them out, I think that PFW probably the biggest winner out of all of us. You know, the PFW signal is tremendous.
It's a good signal.
I do have to, I can hear you in Baltimore very well. WPFW in Baltimore. Yeah, that's not it.
hugely beneficial to WPFW. So
Yeah.
thank you to the whole community, but one small thing I have to point out.
Get you the mic.
So I also want to, Jerry Paris, General Manager of WPFW. Thanks for being here, Jerry.
So thank you to the whole community because it's been a huge improvement for WPFW overall. One thing that you had mentioned earlier was that you guys rehabilitated our shack, our transmitter room. Excuse me. One thing that folks might not have noticed was in the rehabilitation of that room, what is usually a vinyl strip around the wall is copper. You know, so everything is grounded and bolted down, welded down, and we took a lightning hit to the tower. We took a big hit to the tower, no damage. Big thing for us. Thank you.
Yeah.
Can I? About.
I was just gonna say, I've done a lot of field driving since the new antenna went in. I've been down to Southern Maryland, far into Southern Maryland, Chesapeake Beach, down that way. I live in Delaware, so weekly I drive out 50 and 301 to Dover, Delaware. I regularly get up to York, Pennsylvania. I regularly get out to Winchester and Martinsburg out in West Virginia. And I can tell you the antenna is uniformly better across the entire pattern. The circularity is there. And more importantly, the null, what I would call null fill in television is fantastic. Even in the low-lying areas where we would normally get picket fencing and dropouts, the signal is uniform. So it's been a tremendous benefit for us. Thank you.
If I could,
Yeah.
just speaking of anecdotes, about WPFW. So, I was, last summer, I was, in Pigtown, Baltimore, right? I was, with my windows open and I was listening to WPFW and I was listening to some, pretty cool jazz, playing, and there was a nice lady in a car right next to me. And she asked me, what is it? What's the station? So I told her, and she was like, never heard of it. Said, okay, that's interesting. And I said, WPFW. I said, what's dial? So she got, you got a new friend, and I'm sure she spread the news. She loved the station. We were all, both of us were just sitting and humming and moving and having a lot of fun for a few minutes. And I'm sure that before that, she wouldn't be able to hear it, nor could I in Pigtown, Baltimore. So good. That's my anecdote.
Any of the other engineers want to comment? Or you want to say anything, Brian?
I had minimal involvement in this project. I wanted to drive it after they turned it on.
Say, Fred,
Yeah, I mean,
have anybody who's on Zoom.
Yeah, well.
Unmute.
okay, anybody on Zoom, go ahead and unmute if you want to make some comments. I don't think it'll feed back. And just
I'd like to say hello to Tom Silliman.
hi,
We
who's this?
we coming through okay?
Yeah. who is this?
We first met with Bob, his father, and himself, Tom, at One Shell Plaza in Houston. He built a very fine 8-station FM 100 kilowatt master antenna. The mast is still there today with the channel 27 antenna on top because they can't get it off the top of the building. But yet we had a wonderful experience with Tom. We worked elbow to elbow for many nights up there. And we also worked, I think you were possibly involved, I can't remember, at the Senior Road Tower Group project, the 2,049-foot tower south of Houston. But Tom, we're in Richmond, Virginia, retired, and it's a wonderful opportunity to see you and see your fine engineering expertise in person. And we wish you all the luck.
Yeah, the original antenna in Houston was on the Shell building. I designed that antenna while I was in college in the summer of 1969 after I got my 5-year electrical engineering degree from Cornell. And before I went back and got my Master of Engineering degree in one term from Cornell. And then the company got the contract to do the building in January, right after I graduated, so my dad hired me to finish it up, and I got it on the air, and we did a fine thing. I'll tell you a funny story about it. We used a bird through line to do the ion product measurements. And I built a metal cage to put up there because we were right under the antenna on the top floor of the building where the filters were. And every ion product was coming in at no lower than -70, which meant everyone failed. And my father was pretty upset. He said, come on, let's go have a bourbon and water and a steak. Let's go. So we're walking down the road and I said, Dad, I wonder what's in those things. And his arm came out and stopped my chest. He said, what'd you say? I said, well, I wonder what's in those sniffers. He said, come on, we're going back. So we took a panel connector, type in panel connector, and soldered a penny to it on the pin and dropped it in the hole and took all the readings again, and everything was down in the dirt. So he said, all right, go back to ERI and design me a coupler, and we'll come back and redo this again. Well, we never learned how to do couplers at Cornell. That was one thing we didn't do in electrical engineering. So I went down to the University of Evansville's engineering department and bought a book down there and figured out how they work. And the way they work is they measure the magnetic field and the electric field both, and then forward they add up and in reverse they cancel because the current's going the other way. So it makes the magnetic field rotate opposite. And what Bird did was they had the little resistor down inside the field and it was cross modulating. And so I took the line out and put the load on the outside of the coupler so that it wouldn't be in the field. Built the coupler, tested it, took it down to Houston, and then we did the proof and it worked. So I called Bird up when I got back and I said, hey, your sniffers are cross modulating and you can't really use them to measure intermod products. And they said, well, who are you? And I said, I'm Tom Silliman. I work for ERI. He said, well, how long have you been out of college? I said, well, just a couple of years. And they said, look, kid, where are the experts? You don't know what you're talking about. I said, okay. So 6 months later, a box showed up in my office and it was full of sniffers, probes from Bird. No apology for calling me a dumb kid. Just a box full of sniffers, so I couldn't stand it. So I took one down. I took my old 3-line body down and stuck it in, and sure enough, now they work. So, so it was interesting.
Thank you for all your work, Tom.
Thank you, sir. But anyway, my dad was a wonderful engineer. He's a great influence on me. Any other questions?
Anybody online, if you want to unmute?
Chat, yeah.
Steve? Or Jeff, or anybody want to?
Yeah, I'll just make one comment. I just wanted to compliment Tom on a job well done. This is a beautiful design that is really exceptional and it's robust. And this was a challenging job. Thank you, Tom. All signals are dramatically improved. Well done.
If I can say something on that, I think, thank you for that comment, but the truth is the whole engineering team at ERI was involved in this. Our structural engineers doing the tower design and the pole design. Our antenna engineers working with me and Nick Pollin's work on the filter designs and improvements. And so it's a joint effort for our whole team.
Tom, you're the only chief that's not physically here. You have any comments on the system? If you're there, if you can unmute.
Oh, Tom Shedlick.
Yeah, Tom Shedlick, yeah.
Yeah, I'm here. I had intended to come tonight and got caught in an automation problem and wound up having to Zoom in. So I'm glad and thankful for the Zoom call. But it was a wonderful experience to be a part of. I'm of course not in the combiner. I've got that WPGC antenna at the top. But from my perspective, everything went very well. And I agree on the signals. I drove all the signals as well, and I was familiar with the signals on that tower before because I knew about that tower long before Rob had seen it and was fascinated by the fact that actually emanated signals at all. So I was familiar with I was familiar with a lot of the problems, and so I was eager to once the project was finished to drive all those signals, and I was thoroughly impressed.
Go ahead.
I was just gonna cover it for those of you who are in the room. If you haven't signed the sign-in sheet, please do. And if you're holding the sign-in sheet, please see me afterwards so I get it back.
Okay, well, over there.
Over there, okay.
Any comments, anecdotes, Dave?
I'm also seeing that, oh, I'm sorry. I'm also seeing that Bob Clinton is on the call. I want to acknowledge that Bob did the FCC engineering on this at Cavell Mertz. Helped us analyze the null fill and beam tilt. And there is a little bit of both in the antenna. And I really think that, you were talking about Baltimore before. I really think that shows up in Baltimore in particular. I think that we really, just that little bit of beam tilt that is bringing that power back down from the horizon is particularly notable there. I'm trying to remember who I reached out for first. It might have been Cavell. I was living next to the radio station on Connecticut Avenue. I was admittedly, it was a lower level apartment. But if you can imagine, literally my apartment was common wall with the studio. Now, of course, that's not where the RF comes from. But it was ironic that in my apartment, I couldn't get the station. I couldn't get the station 2 miles from the tower in my apartment on Connecticut Avenue. And that plus trying to really grapple with what was going on the tower with the antennas, I was like, there's clearly something here. And then when I heard from the folks at COP, yeah, we've been talking about this for years. And Kent, yeah, we've been talking about this for years. Something's got to be done. It's like, all right, I'm not crazy. Bob, thank you for your help in this. I want to note that. And also Peggy Miles says hello, Tom. She wanted to be here tonight, but she did join the Zoom. We worked with Peggy at the Empire State Building.
I was just gonna say on WMMJ's behalf, yeah, this was a fantastic project. That this has gone on as long as it has. And I know the guys from TOP have wanted it. I have documentation where even Radio One tried this back before it was Radio One, trying to get a master antenna because, we were the little 2 bay at the bottom that had 2 different sizes of pole. We had the 18-inch behind the lower bay and the step down behind the upper bay. Being a Class A, you can only imagine what that was doing to us. Not to mention the fact that we had a huge null to the north because we were pointed opposite from AMU's antenna, so we were pointed almost to the south. Being able to put up a new antenna on a consistent pole that had been circularized by ERI, just night and day difference. I mean, we had coverage that we had never had since that pole went up there. And I've seen the documentation that came with those antennas when they were put up. It was a nice piece of fiction, I think. Would you agree?
And how about your ratings now versus?
Depending on what day of the week it is, yeah, we're now consistently a small A that gets, yesterday we had a 5.5 12 plus, which ties us for number 4 in the market.
Or Class A. Any more questions in the room or comments, anecdotes?
I have an anecdote. When you cut the top off of the tower, the signal in Prince William County, where I live, got much better because of course you're on the WETA site in Arlington. And I thought, I just hope they never finish this project. Loving this excellent coverage. Well, it's never gotten worse again. So whatever is happening up here is markedly better than it was before. Also, the other observation is I've always had a theory about this site and the NBC site that stations from these 2 locations do better down Foxhall Road and in through Georgetown because of the look angle over that ridge.
Yes.
That I suspect stations from this particular site do well. Are you looking forward to hosting other stations in the master antenna at some point?
We are open to anybody that would like to join them.
The one thing I'm interested is, everywhere that I have worked, be it a combined facility or a single station facility, you can identify the locations that you have an antenna problem, because all you have to do is find out where the general manager lives. And that will tell you where you have a signal problem. I have never sat in a meeting with this many people and no one is saying, well, you know, it's really good, except for this. You know, pretty much everybody, like, I remember I talked to the guys at the Hancock building. And I think, I can't remember who owned the one, you know, there are a number of stations there. I can't remember who owned the one particular station that I was buying some consoles from, and I got to have a tour of the Hancock building. And they said, you know, this antenna works great for every station except us. For some reason, our frequency doesn't do well from this location. But this appears to work well for everybody. The other thing I didn't ask, and I suspect people will just freak out and say, you mean you want actually this other thing? Is there a wideband port in there that somebody could use when they're working on their combiner?
Yes.
Cool. 'Cause it's always handy to have that, but you don't always get it.
That's the real advantage of constantly being filtered. With the constant impedance filter, you have an input hybrid you have the two banks of filters, and you have an input hybrid at the top, which is where the station being injected goes in. And then you have an input hybrid on the bottom, which the other stations can go into. The signal goes in and bounces off the tanks and comes back and recombines and goes out the other side. And then that's his area. And that, when you're done with that line of filters, the one that's left, you just put a termination on it just to avoid leakage into the room, and then, you know, whatever the isolation is in the hybrid, which is typically what, 30 dB or so.
40 anymore.
40 anymore. So, you know, if you got if you're putting in 10 kilowatts, and you know, 10 dB down is 1, and so on. So it doesn't have a lot of energy there. So yes, depending on which, when you go through as long as you can take the power and the voltage and the current in the lines, you can use that broad port.
One thing I've noticed, living and working in this area for 40 years or so, is the IM products really went down. And I don't know how to describe it other than, you know, just makes every signal much cleaner.
Yes.
But there had to have been a lot of beating going on that we didn't know about until they cleaned up, and it's like, wow, amazing how good these stations sound now. The tour portion, we're not going to be able to do with the online people. I see Fred Climbs as an engineer, Ken Silliman, haven't seen him in a while. Any of you guys have any more comments, questions, anecdotes?
Yeah, I'd just like to say that I really enjoyed the presentation. It's really well done. And I is both working in broadcast as well as government. I understand how they could, you know, especially government, NASA, wouldn't understand the importance of a tower. It's just like, go ahead and get rid of it. So that was a good insight into making sure that who you work for understands what you do and how important your job is. Thanks for that presentation, and fantastic job on the RF design. Very impressive, very impressive. Thanks. I'd like to add too, that it's a long way in technology since Tom and Bob's first project at One Shell Plaza in Houston. And I'm just marveled at the assembly and the performance of such a project. It's a very impressive project, and hats off to the Sillimans and the ERI technology. It's marvelous, and I was proud to be a part of the One Shell Plaza project in Houston. Good luck, Tom.
Thank you for that. And I'd like to say that the Shell building project, it worked from day one, but then the city of Houston started adding more buildings. So eventually it had to be retired because it was shadowing so bad, but not because of anything else. And then that's when the Senior Road Tower went up, and then I was actually hired to go down and be at the Senior Road Tower when they were installing it. Bob Shirley was putting it up. And he dropped a guy wire and it damaged the wire, so they had to stall. So I left. But then he got the wire up and then he had the antenna ready to go. And as all of you may remember, he was taking the antenna up, but Bob got the brilliant idea to put 2 channels on top of the antenna that Harris had built. And he U-bolted them to a member. And why in the world he didn't just choke the legs? He would have saved that crew's life. But instead he lifted from those 2 channels. And when the tower caught something on the way up, it pulled the U-bolts out. And that's when the guys came down with it. And the one gentleman who's my life hero did a swan dive off of that falling object to his death. That's pretty amazing.
That was a very dark day.
And then later on, when they wanted to redo the antenna, they asked me to quote it the first time around. And I'd get a call from the guy running the project. And he'd say, why are you proposing 17.5-foot sections of rigid line instead of 20-foot sections? And I said, well, because 20-foot sections resonate at 98, 17.5 doesn't resonate in the FM band. And so he would take that information and send it to everybody else bidding and say, okay, I want 17.5-foot sections from you guys. And then in the end, he wound around with my ideas and gave them to our competitors. And then he called me at the end. He said, we decided to throw your bid out because your company's too small to do the job. And I said, you son of a bitch, why didn't you just hire me as a consulting engineer? But then when he got retired, we bid it to replace it. And of course, we got the contract. So it's now our system up there. And I remember when we did the job, the project engineer down there for the Senior Road Tower, he talked to me about the project and he said, I want to switch at the input so I can switch, because you don't understand Houston weather. When the Houston ice forms, your antenna is going to trip and I got to be able to switch. And I said, no, it won't trip. He said, no, you don't understand, it'll trip. I said, no, it won't. Because so we ended up putting the switches in, they're Dasto switches. They've only been used one time, and that's when lightning hit the top bay and burnt the insulator a little bit. And I know that because I went and inspected it that summer, and we took the cap off, and sure enough, you could see the lightning strike inside the cap, and we cleaned it up. So it has never tripped because of ice.
All right, last call for anybody online that wants to do a question, comment, anecdote, because we're going to be doing a tour here soon. And we haven't mastered technology to do a moving Zoom yet.
Can I say something?
Yeah, sure.
It goes without saying, but I want to say it anyway. And I mean this sincerely and actually emotionally. A project of this magnitude requires a team. Tom knows this better than anybody. His people, the way it was delivered, the consultants for Capital Mertz, the mechanical engineering, the RF exposure, all of these are important components. But they all require not only the combined expertise, but they require somebody to be a team leader to manage and coordinate and make it happen. And I want to thank you.
Wonderful presentation. Thanks for putting this all together. We're really, I think everybody agrees this is one of the best presentations we've ever done in SBE.
Yes, so super excited to show everybody this. So we'll probably split the group roughly in half. And then I talked about this before. We'll kind of start, one end to the other. I didn't talk to my other friends who are here on the tower, but we were thinking that we would start at the WAMU room with half the group, and then go from there. And I'm sorry, start at the WAMU room with half the group, start at the combiner with the other half, The combiner group, we will come back through the building. And if you would be into opening your rooms, to show folks your rooms, if you want, no pressure. We'll, just kind of do a swing by. And then we'll reconvene at the WAMU room and switch groups. And then, Andy can do the WAMU talk with that group, and we can go back to the combiner and do the combiner talk with the other group. So with that said, maybe we could just kind of like visually kind of split the roomish. We're sort of roughly balanced. I'm thinking, is this sort of half? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah.
We'll probably stop the Zoom
And we'll
record
probably
right
stop
now,
soon, yeah.
and we'll end the Zoom part of the meeting. For those of you who joined us that on Zoom, thanks very much. We're trying to do as many of these hybrid as we can, and we learn each time a new thing to make them better.